So let's recap where we are. We talked about finding p-values. P-values give you the strength of evidence against the null hypothesis in favor of the alternative. Small p-values are strong evidence. Larger p-values are weak evidence. It seems backwards, doesn't it? P-values less than 0.05 lead us to call a result statistically significant, and we reject the null hypothesis and accept the alternative hypothesis. P-values greater than 0.05 lead us to conclude the results are not statistically significant, and we fail to reject the null hypothesis. So the usual level of significance is 0.05, which is just the probability you're using that the p-value has to be less than for you to reject the null hypothesis. But sometimes we want to use a significance level alpha less than the usual alpha equals 0.05. So we call significance level alpha. In this case, we reject the null hypothesis if the p-value is less than alpha, and fail to reject the null hypothesis if the p-value is greater than alpha. Typical values of alpha which could be used, or could be, 0.1, 0.05, the usual value, 0.01, 0.005. Those are ones that experimenters actually use. The value chosen depends on how, it doesn't look like how, on how strong you decide the evidence should be. So it's mostly a matter of what happens if you make a mistake and declare the null hypothesis false, or what happens if you make a mistake and declare the null hypothesis unviolated. In that analysis of how much damage is done or how much money it costs you, then you can make a decision about what p-value to use, what sample size to use, and all those things that statisticians are hired to do. Because everything is subject to random variation, so you're never 100% sure about anything. So you have to weigh the pros and cons of different ways of analyzing your experiments. So you want to consult with a specialist before you go out there and, say, do some consulting and tell someone, I think you should use a p-value of 0.1 in this case, before you really know what that means. So we'll just be using 0.05 most of the time. That's the accepted value in just ordinary situations. And that's because the 0.05 is considered a small enough probability that that's considered an unusual value that you would not usually see for x bar that's favoring the alternative more than 1 in 20 times if the null hypothesis was true. So if we see it, we think the null hypothesis probably isn't true. We'll have to keep saying that over and over. There we go. Sometimes you'll say not significance at level alpha equal 0.01, but it's considered significant at level alpha equal 0.1 because the p-values maybe not quite small enough to make a 0.05 level or a 0.01 level, but it's smaller than 0.1. So you can have significance at different significance levels. If you're significant at a small significance level, you'll have a result that's significant at any significance level that's larger than that value. We'll talk about this in more detail in the future.